The James Webb Telescope captured the incredible images of Jupiter. What does this mean? Jupiter, the giant planet in our solar system, has been observed in a light that has never been seen before, thanks to James Webb Space Telescope, the newest and most advanced telescope in NASA's arsenal. The James Webb Space Telescope obtained these photographs. The released photos have captured a unique perspective of the planet, displaying in detail its tremendous storms, colorful auroras, dim rings, and two small moons that go by the names Amalthea and Adrastea. Jupiter is home to enormous storms, tremendous winds, auroras, and circumstances of high pressure of temperature, all of which contribute to the planet's busy atmosphere. Recently, the James Webb Space Telescope has taken fresh pictures of the planet. The studies of Jupiter will provide researchers with considerably more information about the planet's interior life. The two photographs were captured by the near-infrared camera located in the telescope. This camera is equipped with 3 specialized infrared filters that highlight various aspects of the planet. The infrared light spectrum has been projected onto the visible spectrum of light because the human eye does not perceive infrared light. In most cases, longer wavelengths are represented as having a redder appearance. In comparison, shorter wavelengths are depicted as having a more blue appearance. The photos produced from the Webb data resulted from a collaborative effort between researchers and citizen scientist Judy Schmidt. Auroras can be seen extending to high altitudes over both the northern and southern hemisphere of Jupiter in the single view of Jupiter that was made from a blend of many pictures from the Webb spacecraft. The auroras shine through a filter projected to redder colors, accentuating light reflected from the lower clouds in higher hazes. This is because the filter is set to a redder hues. Another filter, which is mapped to yellows and greens, reveals hazes swirling all around the north and south poles. The third filter, which is mapped to blues, reveals the light reflected from a more substantial primary cloud. Webb captures an image of Jupiter in its entirety, including its dim rings, which are 1 million times fainter than the planet itself. The two tiny moons, known as Amalthea and Adrastea. It's possible that galaxies are photobombing this picture of Jupiter, evidenced by the blurry dots in the bottom background. This one image sums up the science of our Jupiter system program, which studies the dynamics and chemistry of Jupiter itself, its rings, and its satellite system, Fausch said. Researchers have already started studying the data that Webb collected in order to gain fresh scientific discoveries concerning the planet that takes up the most space in our planetary system. The data collected by observatories, such as Webb, are not sent to Earth in a tiny package. Instead, it consists of data regarding the light intensity detected by Webb sensors. Raw data, including this info, is received at the Space Telescope Science Institute, which serves as the Mission and Science Operations Center for Webb. Mikulski Archive for Space Telescopes receives the data after the Space Telescope Science Institute has processed it into standardized files for scientific study and after it has been delivered to the archive. During the stage of their research, researchers first seek data and then convert it into visuals like these. Even though a group of professionals at the Space Telescope Science Institute is responsible for formal processing of Webb images prior to their public release, amateur astronomers, known as citizen scientists, frequently access the publicly available data repository in order to obtain and process images as well. According to Schmidt, the rapid rotation of Jupiter makes it one of the more challenging cosmic mysteries to study because of the amount of data available. When Jupiter's special characteristics have moved during the time the photographs were taken and they are no longer matched, it might be challenging to combine a series of images into a single view. Jupiter is a planet that orbits the Sun. Occasionally, she needs to make alterations to the photographs on the computer in order to arrange them in a manner that makes sense. "Something about it just stuck with me and I can't stop," she said. "I could spend hours and hours every day." NASA has released a statement praising the exceptional clarity of the photos captured by the James Webb Space Telescope. "We hadn't really expected it to be this good, to be honest," said Dr. Imke de Pater, a planetary scientist and professor emerita at the University of California, Berkeley, who helped co-lead the observations. Jupiter's auroras spread to high altitudes over the planet's northern and southern poles in the newly released photographs. Let's go on to a more in-depth discussion of the picture. The greatest red spot on Jupiter. Incredible levels of clarity can be observed of the Great Red Spot in the photographs taken by the NASA telescope. As stated by the space agency, the phenomenon in question is a gigantic sandstorm that is so big that it may engulf the Earth. Since it was reflecting an abnormally high quantity of sunlight at the time these pictures were taken, the shade of it is shifted to a more white appearance here than it would have been otherwise. According to Heidi Hamel, an interdisciplinary researcher for solar system investigations at Webb and the vice chairman for science at Aurora, the brightness here indicates high altitude, so the Great Red Spot has high altitude hazes, as does the equatorial region. The composition of Jupiter's upper atmosphere. The James Webb Space Telescope captured two different images of Jupiter's face. On the one hand, the planet itself is the only thing seen. On the other, its surroundings may also be seen. The near-infrared camera, outfitted with a range of filters that can be set to various wavelengths, was used to take the photographs that were used to construct them. When translating information to visible light spectrum, researchers follow the rule that dictates attributing blue color to shorter wavelengths and red color to the longest wavelengths. This is because infrared radiation is not perceived by human eye and hence cannot be seen by humans. In the case of photographs of Jupiter, the hue red is associated with the auroras that may be found in the planet's poles, as well as sunlight that is reflected from the bottom edges of the clouds and haze that are found in the upper atmosphere. The haze surrounding the north and south poles corresponds to the yellow and green colors, respectively. The light reflected by the planet's primary cloud cover gives off a blue color, representing this phenomenon. A single image of Jupiter captured by jwst reveals a number of peculiar phenomena currently happening in the atmosphere of Jupiter. When clouds or vortices are higher up in the atmosphere, they are able to reflect more sunlight, which causes them to appear brighter. Because of this, the well-known big red spot in the picture seems white. It would appear that the various brilliant dots and streaks are representative of the very high cloud tops that are prevalent in turbulent storms. The numerous bright white spots and streaks are likely very high-altitude cloud tops of condensed convective storms, said Heidi Hamel, Webb interdisciplinary scientist for solar system observations and vice president for science at Aurora. Jupiter's moon and ring system. A view of Jupiter captured with a wide-angle lens reveals the region immediately surrounding the planet. We can see the rings on it. They are extremely faint, almost 1 million times fainter than Saturn's rings, and are primarily composed of dust. In the picture, you can also make out two of Jupiter's moons, Amalthea, which is around 200 kilometers long, and Adrastea, which is approximately 20 kilometers long. Galaxies so far away that they appear as blurs in the background are distant background galaxies. The diffraction rays emitting from the moon are also apparent in the photo. However, the moon itself is not visible because it is outside the frame. This is a visual phenomenon that occurs as a result of the design characteristics of reflector observations. So, that was it for today's video, guys. We hope you enjoyed it. If you do, make sure to like and leave a comment. Let us know in the comments below what kind of content you want to see in the future videos. Until the next video, take care everybody.